All right, so today's lesson is going to be just focusing on dividing. On Tuesday when we met up, we refreshed our memories in simplifying the radicals, when we multiply by radicals as well. So today our main focus is dividing, okay? And when we are dividing radicals, there's a rule that you need to remember, okay? The rule basically states is that you are not allowed to leave a radical in the denominator, okay? If you have a radical in the denominator and you cannot divide it, then you must get rid of it. And the only way by getting rid of it is by multiplying by itself. So basically, if you multiply by itself, you're making it into a perfect square because you're doubling it and you get rid of the radical. So before we get into the fractions, I'm going to just show you. If I have radical 3, okay? If I multiply radical 3 by radical 3, this will give me radical 9. And what's the square root of 9? 3. So you see that? So when I multiply by itself, I'm basically getting rid of the radical and just stating what is a double of, which is a double of 3. Okay, so this is what we're going to be doing in order to rationalize the denominator. It's called rationalizing the denominator. Okay, so for example, okay, I'm going to start off light. Okay, here is example 2a, 3 divided by radical 2. Now these two numbers, you cannot divide it because one is outside of the radical and the other one is inside. Okay, so you can't divide these. And plus, they don't have anything in common. So in order for me to simplify this fraction, I need to get rid of this radical. So I need to rationalize the denominator. That's what it's called, the terminology, okay? In order to rationalize the denominator, I have to multiply by itself. So I'm going to multiply, and what you do to the denominator, you must do to the numerator as well, okay, to balance it out. So I'm multiplying by radical 2 to the denominator. I must multiply radical 2 to the numerator as well. Okay, so now I multiply straight across. So 3 times radical 2, okay, will just give me 3 radical 2. Because you can't tell me is equal to radical 6 because one number is outside of the radical and another one's inside. So your answer for the numerator is just 3 radical 2. Over the square root of 2 times square root of 2, what does that give you? Square root of 4, right? And what's the square root of 4? 2. So basically, look, when you're multiplying by itself, your answer would just be 2 because you're making it a perfect square of what number? 2, okay? Now, this is your final answer. Do not cross these two numbers out. You cannot cross these out. They don't divide. One is inside the radical and the other one is outside. They have 2 different values, so therefore you cannot divide them. So your final answer is 3 radical 2 divided by 2. All right, and that's it. You're done. How do I know I'm done? I'm not able to divide anything, and I don't have a radical in the denominator. So let's go to the second example, okay? Now, you have both numbers inside the radical, so you're able to divide them. But does 5 and 6 have any number in common? They don't, right? So therefore, you can't divide them, okay? So I know I have to rationalize the denominator by multiplying by itself. So I'm going to multiply top and bottom by its radical, okay? So now I'm going to multiply straight across. I get radical 30 over, I'm not going to skip a step this time. I get square root of 36 because 6 times 6 is 36, right? So now my next step is, okay, radical 30. I can't simplify it because it doesn't have a perfect square in it. Okay, so it just stays as radical 30, but I know the square root of 36 is 6, okay? This is my answer. I cannot divide the 30 or the 6 because the 30 is inside the radical. Okay, so you can only divide numbers inside the radical with numbers inside the radical. So your final answer is radical 30 over 6. Okay. All right, let's do some harder ones. Okay. So you have a fraction. Both numbers are inside the radical. Okay, so you have to first ask yourself, can I divide these two numbers? Do they have something in common? So I have square root of 18 divided by square root of 3. Can I divide 18 by 3? Yes, right? So I get radical 6. So guess what? When I divide, because they're both inside the radical and they have a factor in common, I divide by 3 to both numbers and I'm just left with radical 6. I'm not left with the fraction, so guess what? I don't need to rationalize anything. So my final answer is radical 6. Done. All right, let's go to B. Now, at the beginning of the school year, we learn division by exponents, okay? Same rules apply. When I'm dividing, I subtract my exponents, all right? So I have 2 numbers inside the radical. I'm able to divide them. So now, let's first divide by the numbers. What's 100 divided by 5? You get 20, okay? X squared divided by x, I subtract their exponents, so 2 minus 1, I'm left with x to the first, okay? So then you ask yourself, okay, do I have another step? Am I done? And the answer is no, because 20 has a perfect square within it. So that tells me I got to break this up. I have 4 times 5. Okay, square root of 4, what's square root of 4? 2. And then these two are not perfect squares, so they stay inside the radical. So your answer is 2 radical 5x. Okay, so you always constantly have to ask yourself the question, do I have any perfect squares inside my radical? If I do, that tells you, okay, I still have more steps involved. All right, 2 more, then I'm done. Okay, so here, both numbers are inside the radical. You got to ask yourself, do they have a factor in common? So does 24 have a factor in common with 10? And the answer is 2, right? So because they have a factor of 2 in common, I'm going to divide by 2 to the 24 and to the 10. So 24 divided by 2 is 12. 10 divided by 2 is 5. Okay? Then I got to say, okay, what can I do with the x's? All right, I'm able to divide, and I'm left with 1x here, right? And then the y's would just cancel. So I'm left with square root of 12x divided by square root of 5. Am I allowed to leave a radical in the denominator? No, right? So I got to rationalize it by multiplying by a radical 5. Okay, so now I'm going to multiply straight across. So what is 12x times 5? Square root of 60x over 5, right? Because square root of 5 times square root of 5 is 25, which gives you 5. Okay, remember, when you double it, you just take it out. All right, then 60. Does this have a perfect square? So there's many steps involved. Yes, it does. It has 4 times 15. 4 is a perfect square of 2. So your final answer is 2. You got to pull this out. You're left with square root of 15x over 5. So these are the more challenging ones because you have to divide first. Then you got to rationalize the denominator. Then you got to look at the radical. Does it have a perfect square? If it does, I have to break it up and take it out. Okay? So your final answer is 2 radical 15x divided by 5. All right, last one. All right. So again, they're both inside the radical. I'm able to divide it. Okay? So 45 and 18, the factor that they have in common is a 9. So I'm going to divide 9 by both. So when I divide 9 by both, 45 divided by 9 is 5. 18 divided by 9 is 2. Okay? Then I'm able to subtract the exponent, so I'm left with x squared and y squared. All right? So my next step is, can't I take the x and the y out of the radical because aren't they perfect squares? Because they're evenly divisible by 2. So I'm able to take out the x and the y. I'm left with the 5, and I'm left with radical 2. Is this my final answer? No, right? Why? Because I have a radical in the denominator. So now I have to multiply by radical 2 over radical 2. So what do I get? xy, that was outside. 5 times 2 is 10 over 2. Do we all understand why it's 2? Because radical 2 times radical 2 gives you radical 4, and the radical 4 is just a 2. Okay? All right, so that was today's lesson in rationalizing denominator, okay? Try the classwork, and then when we meet up on Zoom, you could ask me any specific questions that you may be having.